So let us discuss a question from engineering mechanics. So here you have a shell, hollow cylindrical shell with open top, and we need to find out the center of mass of the cylinder taking origin of the coordinate system and the center of the bottom. Okay, so here because it's a shell, so what we do is we actually we will consider the thickness as well. So don't worry about that. But thickness is very small. Okay, that is the assumption here. Okay, and this is it. Okay, so we'll just take it like this. Okay, so this is the cylindrical shell is component number 1, bottom is component number 2, and thickness we assume that it's a uniform thickness. So this is thickness and this is thickness, though nothing has been said about thickness, so thickness may not be important in the center of mass, but we will just consider it. So the bottom is basically a circular disc, kind of a circular disc. The bottom we are asked to take as a center, and we need to find out the, so obviously it is a symmetric about y-axis. So center of mass will, the body is symmetric about this axis passing through this, so center of mass will lie on this. Okay, but now at what distance is what is required? So that is what the height of the center of mass from this is required. Okay, so this is object 2, this is object 1. We model it as a discrete. So the center of mass, given the masses of this, so m1 into y1, that is mass of, so basically we are taking the moments of the masses to get the, just like you for the area centroid you take moments of the area, we take moments of the masses to get the centroid of the masses. So m1 y1, basically mass m1, the center, the centroid or the center of mass for the mass m1 is y1 from the origin. So we take this as our reference. Okay, the whatever is given in the problem, that is our reference. From this, the y1 is the center of mass of the body 1, m2, y2 is the center of mass of body 2 by summation of mass. So this is basically the technique in finding out the center of mass. So now we'll start with the one. The one is a cylindrical shell. So cylindrical shell, so it's basically, it's a, if you look from the top, the cylindrical shell is like this. Okay, so 2 pi r is the area. So what is the area of cross section? It's a very small thickness. So mass we can write density into volume, and volume is nothing but area of cross section into length. So area of cross section, because it's small, so we can take 2 pi r into t. T is the thickness, and volume is so this is area of cross section into length. So length is again okay, so length, how much is this length? So because the height is given as h, so that is again from till this point, right? So basically, I mean, you can say that it is till this much. Okay, this much is our body one. So height h, you can say, though there might you can argue that if h is measured again from the center of this, then the height of this would be h minus something or h plus something. It depends on how much you consider, but then that thickness is very small, so h plus t by 2 is also more or less h, because we are assuming that thickness of the shell is very small. So 2 pi r t h is something which we can write for mass m2, and its centroid is h at h by 2 from here, because h is again measured from this reference, that's what we assume, and h by 2 will be the centroid of this. Okay, so this is m2. Now m2 is basically a circular disc of till this much. Okay, this is what we take, till this much is my m2 circular disc. So this will be, again the radius is r, so pi r square is the area into thickness is the volume into density, so that is mass 2, and y2 is 0 because your origin for the calculation of combined center of mass, your origin is at the center of mass of disk 2, because the center of mass will be at the center for the disk. So y2 is 0. So now we substitute everything here, rho 2 pi r h into t plus m2 into y1, which is y1 is h by 2, plus y2 is 0, so we don't write here. M1 plus M2 is again rho 2 pi r R, okay, somewhere I have written small r, but it's everything is capital R. So 2 pi r T H is there, plus rho pi r square into T. So the thickness gets cancelled, that's why there was nothing mentioned about thickness. You can do the same problem without considering volume, you can consider area also, it doesn't mind, the answer will be same. But just as a full-fledged thing, I always write mass as density into volume. So you have to consider thickness, but then it gets cancelled out, density also gets cancelled out, and so what is left is 2 pi r h square by 2 at the numerator and 2 pi r h at the denominator plus pi r square at the denominator. So pi r gets cancelled, okay, so and at the pi r v gets cancelled and h square is 2h plus r. So that is the thing, and now we substitute, it's 10 centimeters, so 10 square by 10 plus radius is given as 2 centimeter, so it comes about 100 by 22. Okay, so 100 by 22, so that is roughly 4 point, so let's use a calculator quickly. So 100 plus 4.54, 4.5, okay, 54 centimeter is the answer. So that is the height. Now remember that if it had been a total closed from the bottom, then it will be h by 2 roughly, because more mass is there because of the circular disk presence at the bottom, more mass is there, so the center of mass will be below h by 2 and h, so below 5. So you have to get something below 5, and that is, so to be precise we have to do these calculations and we get 4.5. So just basic use of this formula, calculate masses correctly, put everything correctly, so you'll get 4.54, 4.5. Okay, thank you.